Hello, my name is Natalia Fernandez. I am a postdoctoral research at the University of Burgos. I am working on the toxicology group, and today with my colleague Mario, I'm going to present the chapter 12. It's about the safe and sustainability by design. The points that are going to talk here are the following: an introduction of safe and sustainability by design, a safety and sustainability dimensions, at the end the conclusions. European Green Deal is one of the priorities of the European Commission, which aims to transform Europe's current economy into a greener and more sustainable one. With the Green Deal, the chemical strategy for sustainability has as object to reduce the impacts on human health and environmental associated with the chemical products, materials, and service commercialized or introduced onto the European market. Its action plan is the development of a framework to define safe and sustainable by design materials and chemicals that should be contribute to achieve the Green Deal ambitions beyond the current regulatory compliance. The objectives of the present CCBD framework are the following: drive innovation towards the substitution of or minimization of the production and use of substance of concern, providing the guidance on how to develop the criteria for safe and sustainable materials and chemicals, and how to assess those against this criteria, minimizing or as far as possible elimination the impact on the human health, climate, and environment along the chemicals and materials entire life cycle, and sharing the sustainability circularity. And finally, enable the comparative assessment of chemicals and materials based on safety and sustainability performance for a given function and application context. The aim of CCBD framework is to support the design and the production of safe and sustainable chemicals and materials with the innovation and design phase. In this context, the concept of safety is an integral element that refers to human health and environmental safety aspect. In the context of the chemicals and materials, it is related to absence of the unsuitable risks for humans and the environment, preferably ensured by avoiding the chemicals with intrinsic hazard properties. Another option is the sustainability, the ability of the chemical materials to deliver its function without extending environmental and ecological boundaries along its entire life cycle, while providing welfare, socioeconomic benefits, and reducing the externalities. The concept of safe and sustainable by design implies the design or redesign of safe chemicals and materials, reducing the negative impacts on human health and environment. During the design phase, several principles can support the integration of CCBD considerations. The process development can be monitored using the technology readiness level, and at each stage quantitative and qualitative new information may be available for the assessment. The safety and sustainability assessment should be performed at early TRL to ensure that application of principles is resulting in a good performance. Moreover, the safety and sustainability assessment is needed to take into account different aspects to give a more comprehensive picture. The safety and sustainability assessment is composed by 5 steps, being the 3 first related to the safety aspects, while the step 4 deals with environmental sustainability assessment, and the last one, the step 5, it covers the socio-economic dimensions. The step 1 is related to the hazard identification of the chemical material based on the intrinsic property of the chemicals and materials in order to identify the hazard profile, following the regulation that considers 3 main classes of hazard, such as human, environmental, and physical hazards. The aspects included in this assessment are included in 3 groups. The group A are composed for the most harmful substance, or including substance of very high concern. These hazard properties from the criterion H1. The group B includes the most harmful substance and substance of very high concern that are not including group A. These hazard properties from the criterion H2. And finally, the group C are composed for all the hazard classes that are not in groups A or B, and these hazard properties from the criterion H3. The step 2, it's about the human health and safety aspect in the chemical material during the production and processing phase. In this step, it is necessary to evaluate the physical property of the chemical materials, the hazard of the chemicals employed during the process, the amount of the chemical material, the frequency and the duration of exposure and the potential route of exposure, and the operational condition and the risk management measures. The result is a categorization into a different risk levels which determine whether the risk is acceptable or not. And the step 3, it's about the human health and environmental aspect in the final application phase. In this step, it's necessary to evaluate the hazard of the chemical materials, their physical properties, and the concentration employed in their application as the use condition, and moreover the frequency and duration of the use. Now my colleague will continue with the step 4 and 5 and the conclusions.
Hello, my name is Mario Santiago. I'm a postdoctoral researcher in the University of Burgos. I'm dealing mainly with sustainability and life cycle assessment. I'm going to present the sustainability dimension of the Safe and Sustainable by Design framework. First, we have the step 4, which is related with the environmental sustainability assessment. Here, all the impacts along the entire chemical and materials life cycle is assessed by means of a life cycle assessment. And there are different impacts, and in this case, the recommended method is the product environmental footprint from the European Commission. And this impact could be aggregated in 4 different groups. First, we have the toxicity with the human toxicity and the ecotoxicity. Also, another main impact, which is the climate change. Then we also have the pollution group regarding ozone depletion, particulate matter, ionizing radiation, photochemical ozone formation, and also acidification and eutrophication. And finally, the group for resources, where we have the land use, the water use, and other kind of resources. And then there is the step 5, which is the socioeconomic assessment. This step is still in an exploratory phase, but we can separate it in 2 main pillars. First, the social sustainability, which is based on the social LCA methodology. And here there is an approach based on the selection of the different relevant social impact categories, the modeling of the whole supply chain of this chemical and material, the different assessment of all the countries and sectors involved in these supply chains, and finally the identification of the different social hotspots, such as for instance, the child labor, fair salary, forced labor, and other social issues. And then we have the economic sustainability, which is based on the life cycle costing methodology, including different aspects. We can separate it in 3 different approaches. First, the conventional LCC, which includes only the internal cost of the material or chemical. Then the environmental life cycle costing, which also use the environmental externalities. And finally, the societal life cycle costing, which adds the societal externalities. Here also, it could be include different analysis of benefits. And finally, to conclude with this chapter, the framework that is being shown in this chapter is proposed to underpinning the different principles for the stakeholders. It also provides guidance on how to develop a criteria for a safe and sustainable by design chemicals and materials. Also, this framework moves on towards the green industrial transitioning, substituting or minimizing the impact on the production, and also the different substances of concern, to finally minimize the impact in the environment and also on the health. It also adopts a hierarchical approach in which safety aspects are considered first, and then are followed by the environmental, and finally the socioeconomic ones. And also it considers a redesign phase in which the different guiding principles are proposed to support the design of chemicals and materials in a safety, environmental, and socioeconomic sustainable way. So thank you for your attention, and we hope you have gained some insights about the safe and sustainable by design framework.